Okay, so just a review of Unit 3, Measure in Circles. So number 1, it says a circle has a radius of 40 centimeters. So which of these is closest to its area? So I want to know what is the closest. So that means we need to estimate. So I know to find the area of a circle, I have to multiply pi times the radius squared. So that tells me pi times my radius of 40. Odd shape there. So 40 squared. So I know that I'm going to need to do 40 times 40 and then multiply that by pi. Well, I know 40 times 40, so even if I had 40 times 10, that would be 400. So that automatically tells me that D and C could not be possible answers. So then I just need to reason about my other two possible answers. So I know that 40 times 10 is 400, but since I needed to multiply by 40, then I could just multiply that by 4 now. So 400 times 4 would be 1600. And now I would need to multiply that times pi. I know pi is 3 point something. So even if this was approximately 2,000 times 3, that would only be 6,000. So I know that my answer would not be more than 6,000. So that tells me that B would be closest to my area. On number 2, it says the shape is composed of squares and quarter circles. Select all the expressions that represent its perimeter. So I know that it is made up of squares, which tells me that each side length is the same. So that means this side length is 7 units, this is also 7 units, and this is also 7 units. So I know each of the dimensions for the outside parts of my squares. So now I just need to determine the distance around these 2 quarter circles and these 2 quarter circles. Well, 2 quarter circles makes a semicircle, which is half of a circle. So in order to find the distance around the semicircle, remember we just find the circumference of the circle and divide that by 2. So circumference is pi times diameter. But I'm going to need to divide this by 2 since it's a semicircle. So that's the same thing as saying pi times the radius. Well, since this distance is 7 units, that tells me that it would be my radius of my semicircle. So the distance around one part of the semicircle would be 7 pi. And since it is the exact same on the other end, then this one is also 7 pi. So I would have 7 pi plus 7 pi. And then I have 1, 2, 3, 4, 5, 6 sides that are 7 units. So I need 1, 2, 3, 4, 5, 6. So that's 7 pi plus 7 pi plus 6 sevens. And it wants me to select all the expressions that would represent that. So we have 42 plus 14 pi. So I know that 7 pi plus 7 pi is equal to 14 pi. And I have 6 side lengths of 7 units. And 6 times 7 is 42. So A would be equivalent. B, so I have 1, 2, 3, 4, 5, 6. So I have 6 sevens, so that part checks out. But then I have 3.5 times pi plus 3.5 times pi plus 3.5 times pi plus 3.5 times pi. So I have 4 of those. So 3.5 plus 3.5. Well, I know 3 and 3 is 6, and then 1/2 plus 1/2 is 1. So 2 of these is equal to 7 pi, which is the same thing that I had above. So B is also equivalent. And then if I look at C, it says 91 plus 14 pi. Well, since I know that 42 plus 14 pi is an equivalent expression, then I know that C could not be, because my 14 pi didn't change. Therefore, if I add 91 to that and 42, I'm not going to get the same answer. So I know C would not be equivalent. Same thing for D. If 14 pi plus 42 is equivalent, then I know that multiplying pi by a larger number and then adding an even larger number would not give me an equivalent expression. And then on E, so I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I have 10 sevens. And so there's no pi there. And I know that 42 plus 14 pi was equivalent. So 1, 2, 3, 4, 5, 6. So I know these 6 is equal to 42. And if I have 4 sevens, that is equal to 28. And I know that 14 times pi is 14 times 3.14. And then if I look at my tens place, so 10 times 3 would be 30, which is already more than 28. So E could not be an answer. So A and B are my only expressions that represent the perimeter. Number 3, it says select all true statements. So I have 3 circles. So A tells me that circle A has a circumference of pi. So looking at circle A, I know to find circumference, I multiply pi times the diameter. And circle A gives me a radius of 1/2. So that tells me that my diameter would be 1 total unit. So the circumference of circle A would be 1 times pi, which is equal to pi. So A would be true. B says that circle B has a circumference of pi as well. Well, looking at B, I notice that my radius is equal to 1, whereas on circle A, my diameter was equal to 1. So I know that my circumference would be my diameter times pi, and the diameter of circle B is 2. So B would not be correct. C says that circle B has an area of pi. So area is pi times the radius squared. And it tells me that my radius is 1. And I know that 1 squared is the same thing as 1 times 1, which is 1. So my area would be equal to 1 times pi, which is equivalent to just pi. So C would be true. D says that circle C has an area of pi. Well, since we know C is true and the radius was 1, I know that that would not be true for circle C because my diameter is now 1, which means my radius would be equal to 1/2. So D could not be true. Okay, E says that pi is the constant of proportionality relating the radius of a circle to its circumference. So this basically means that pi times the radius would equal the circumference. And I know that that is not my formula because I would also have to multiply by 2. So E is not correct. And F says that pi is the constant of proportionality relating the diameter of a circle to its circumference. So that means that the diameter times pi would give me circumference, which is true. So F would also be true. So for the circumference to be equal to pi, then the radius would have to be 1/2 or have a diameter of 1 unit. For the area of a circle to be equal to pi, then your radius has to be equal to 1 or a diameter of 2. Number 4, it says for each quantity, decide whether circumference or area would be needed to calculate it. So A says the distance around a Ferris wheel. So think about if I have a Ferris wheel here. So all my people are going around on a Ferris wheel. And I want to find the distance around that. So distance around would be the outside, one circle around. So that tells me that I would need to be finding the circumference. B says the amount of paint needed to paint a bullseye. So think about if you have a bullseye, you have multiple circles, and you're painting that. So in order to paint that, you would need to be covering the full surface, or actually every other circle. So then that tells me that to cover the entire area that I'm needing to paint means I would need to know the area. C says the amount of whipped cream needed to go around the edge of a pie. So think about if I have a pie here and I'm wanting to put whipped cream just around the edges, then that's just around the outside, which is circumference. D says the amount of material needed to make a drum head, which is the part of the drum that you hit. So if you have a drum here, ignore my artwork, and you're wanting to make a drum head, which is this part here. So it would take up that whole space, which tells you that you would need to know the area. Number 5 says a class measured the radius, the circumference, and the area of various circular objects, and the results are recorded in this table. So it says, does there appear to be a proportional relationship between circumference and area? So in order to find that, I would need to figure out if there's something I can multiply the circumference by to get the area each time. Well, I know that 25 times 2 is 50. But I also know, looking at here, this one's easy. 50 times 2 should be 100, not 201. So that tells me that there's not a proportional relationship, because 25 times 2 is 50, but 50 times 2 is not equal to 201. B says the equation area is equal to 1/2 times the radius times C. Describe the relationships in the table. So let's look at our first row here. So it's saying area is 1/2 times radius times circumference. So then I can just plug in my answers. So I want to know if 50 is equal to 1/2 times my radius of 4 times my circumference of 25. So I know that 1/2 times 4 is just half of 4, which is 2. So I have 2 times 25. So it's 2 times 25, 50. And yes, those are equal. But I don't need to always just depend on one, so I need to check another one as well. So let's use our next one. So now we have our area of 201 is equal to 1/2 times the radius of 8 times the circumference of 50. So I know 1/2 of 8 is equal to 4. And 4 times 50 would be 200. So I know that is not equal, and it's only 1 unit off. So you could always check another one just to make sure. So let's check this last one. So 452 should be equal to 1/2 times the radius of 12 times the circumference of 75. 1/2 of 12 is 6, and 6 times 75. 6 times 75 is 450. So those are also not equal. So this equation does not fully describe the relationships in the table, because you notice that because it worked on the first one, you would normally want to say yes. However, when you check other areas in circumference, you realize that they are not actually always equal. Number 6, it says this figure is made from part of a circle and part of a square. So first it wants to know what is the perimeter to the nearest unit. So that means I'm going to round to my ones place. So first I need to break my shape up. So I have a side length of 2 units, a side length of 5, another side length of 5, a side length of 2, and this dotted area is not a side length. That's just letting you know that the distance of that space is 3 units. So in order to have the full perimeter, I also need to know the distance of this section. Well, I notice that this section is a quarter circle, which means 1/4 of a circle. So I would need to figure out the circumference of that. So the circumference of a circle is pi times the diameter. Well, I see that my radius here is 3. So that tells me that my diameter would be 6. So 6 times pi would be the circumference of the full circle. But since it's only 1/4 of a circle, then I only need to know what 1/4 of this is. So 6 times 1/4 would be 6/4, which is 1 1/2. So my circumference of the quarter circle is actually 1 1/2 times pi. Or I could simplify that as 3/2. So the circumference of this is 3/2 times pi. But it wants to know to the nearest unit, so I need to go ahead and multiply this out. So 1 1/2, or 1.5, times 3.14 is 4.71 units. And it says round to the nearest unit. And I did not spell that correctly. So that would be approximately 5 units of just the semicircle. So this is approximately 5 units. But I need to add my other side lengths. So I had a 2, a 2, a 5, and a 5. So I need to add my 2 side lengths of 2 plus my 2 side lengths of 5. So here's 4 and 5, and 5 is 10. So the total perimeter is equal to 5 plus 4 plus 10, which is 19 units. Okay, now it wants to know what the area of this figure is to the nearest square unit. So again, that's rounding to my ones place. So with area, that's when I need to figure out my different shapes. So I'm going to break this into 2 rectangles. And then I have my semicircle as well. And we're going to pretend those lines are connected. Okay, so I have the area of this section, which would be a height of 2. A height of 3 and a width of 2. So 2 times 3 tells me that the area of this section is 6 square units. And at the bottom, I have a height of 2 and a width of 5 units. So 5 times 2 is 10. So that tells me the area of this section is 10 square units. And then I need to find the area of my quarter circle. So area of a quarter circle. First, I need to know my full circle area. Be pi times the radius squared. Well, I know that my radius is 3. So pi times 3 squared. 3 times 3 is 9, so I have 9 pi. But again, this is only 1/4 of a circle, so I need to know what 1/4 of this is. So 9 divided by 4. So 9/4 pi. Or I could also write that as 2 1/4, or 2.25 times pi. Multiply 2.25 times 3.14, and that tells me that the area of my quarter circle is approximately 7.065 square units. But then I had one rectangle that was approximately 6 square units, plus my second rectangle that was approximately 10 square units. So the total area would be 7.065 plus 6 plus 10, which is 23.065 square units. And it says to round it to the nearest square unit, which will be the ones place. So it's approximately 23 square units. Okay, number 7. A painter needs to paint the bottom of a circular pool. The pool has a radius of 30 feet. So first I'm going to draw my circle that I'm working with so I can visualize it. So I have a circle with a radius of 30 feet. And I'm covering the whole bottom of the circle. So I know I'm going to need to know the area. So first I need to find area of this pool of the bottom. So area again is pi times the radius squared. And it tells me that my radius is 30 feet. So pi times 30 squared. So 30 squared is 900 times pi. So 900 times 3.14 is 2,826 square feet. Okay, so it tells me that a store sells 5-gallon cans of paint, and each gallon of paint covers 300 square feet. So I need to know what the smallest number of 5-gallon cans that the painter must buy to cover the bottom of the pool. So first I need to figure out how many square feet I can cover with one 5-gallon can of paint. So 1 gallon is let's do this. I have my gallons, and then I have my square feet that it covers. So when I had 1 gallon, it could cover 300 square feet. So that tells me that a 5-gallon can would cover 5 times that amount, which would be 1,500 feet. So each 5-gallon can covers 1,500 square feet, and I'm needing to paint 2,826 square feet. And it wants to know what's the smallest number that I can buy. Well, if I'm needing to paint 2,826 square feet, and each can covers 1,500 square feet, then that tells me that I need 1.884 cans. And that's 5-gallon cans. But it wants to know what is the smallest number that I can buy. Well, since I can't buy part of a can, then I would need to round up in this situation. So 1 can is not going to cover it. And I know that I need 0.884 of another can, which is over 80% of that can, almost 90%. So it's almost another full can. So that tells me that I need 2 5-gallon cans of paint would be the smallest number that I could purchase.